Hello everyone. Today we're looking at 1.3 part 1 solving equations. As your homework here, I've put a screen capture on Facebook for the 1.3 homework. Notice the numbers you're doing 1 to 6 and 9 to 18. Okay? Okay, so here this first part, we're trying to translate guys between verbal and algebraic expressions. So expressions don't have equal signs. We're using variables, things like that. Okay? And so, in order to translate, guys, we need to know, like sum, that means add. More than, increase, those are other words for add. Okay? Decrease, deduct, difference, those are words for subtraction. Multiply, times. Okay? Those are words for multiplication. Quotient, divide, division, words for division. Squared, cubed, those type of words. All right? And so we're going to use those to try to take like a sentence like we see here in part A, 2 more than 4 times the cube of a number. Okay? And we want to be able to write what that looks like using algebra. So, guys, anytime you see this a number, you're going to see it a lot in these next few problems. Okay? That means we're going to have to use a variable. We're going to have to define a variable. So let's say that for all of these examples, let's say n is a number. We're going to use n for our variable in this case. You could use x, guys. Defining a variable, you can use whatever letter you'd like. You just need to say what it's equal to. Okay? So 2 more than 4 times the cube of a number. 2 more than, so that's going to be 2 plus. More than is a plus, so 2 plus. What are we adding? 4 times the cube of a number. 4 times our variable, the cube of our variable. Cube of a number. Right. For B, the quotient. Quotient means dividing. So I prefer to write dividing as a fraction. So what are we dividing? 5 less than a number. Less than, that's subtraction. We're going to start with our variable. This is going to be n. And we're decreasing it by 5. So it's actually going to be n minus 5. This is one where you got to kind of flip those terms. It's 5 less than n. So n minus 5. And 12. That's the second part of our quotient. We're doing a division. So n minus 5 over 12. Okay. I'd like you guys to try 1a and 1b. So pause and do that. Okay. And so hopefully you guys have tried those. The cube of a number increased by. So we're going to have to do the cube of a number. That's our variable cubed. N cubed. Cubed of a number. Increased by, so plus, what are we increasing it by? 4 times the same number, 4 times our variable. Okay. 3 times what? 3 times a difference, so difference means subtraction, so the difference of a number and 8. So those are 4 examples there of writing algebraic expressions. Again, remember and try to make sense of what do these words mean. Increase, decrease, difference, sum. The same words we were kind of just talking about. Okay? Guys, these are all expressions. Okay? Equations have equal signs. Or in equation sentences, you would see the word is. All right? Or you equals, okay, and that's what makes things equations. Those first 4 were expressions, no equals, no equality. All right. So in these examples, we're going to write a verbal sentence. We're going to kind of go the other direction. Keep in mind there's equals, so we're going to do that. How could we write this left side? 6 times x. The product, we could use the word the product. That's multiplication, or we just 6 times our variable. 6 times a number And then for our equal sign, we say is. How do we write that? It's just a number. So 6 times a number is 72. 72. All right, left side of this, n plus 15. Let's use the sum. The sum of variable, so a number, and 15 is, what's it equal to? 91. Okay. A couple more examples there with equations. Guys, we're going to practice solving equations here in a minute. Guys, these are some concepts that we talked about there in, I guess this would more be the first semester of geometry, so probably about a year ago for most of us in here. Reflexive property, guys, everything's equal to itself. 1 equals 1. X equals X. B plus 12 equals B plus 12. Everything's equal to itself. Symmetric property, this is just like saying X equals 2 and 2 equals X. That means the same thing. That's true. Okay, that's the symmetric property. Doesn't matter what side of the equal sign it's on. Transitive property, kind of like a chain here. A equals B, B equals C. Well, let's get rid of the B's. We can say that A is C. A equals C. And then substitution, guys, you know how substitution works. You guys, you can replace A with B if they're equal. You can replace B with A. Goes both ways there. Okay. Guys, these next couple of ideas, these are kind of like our key concepts. It's addition and subtraction properties of equality, multiplication and division. These are like our golden rules if we're solving equations. Golden rules, we'll call it of algebra. That's just my made-up name for them, okay? What you do to one side, you have to do to the other, okay? If you add a number to one side, you got to add it to the other. If you subtract from one side, you got to subtract from the other. If you multiply by one side, you got to multiply by the other. Divide by one side, you got to divide by the other. Okay? Guys, here we've got some one and what I consider two-step equations. I guess these B examples, you could call them two-step or one-step. I'll show you guys both ways, one on each. But the A examples, I guess we got n minus 3.24, so we just add 3.24 to both sides. And you're getting n equals what, 45.34. Okay. So 4a, guys, similar. You're subtracting 14.92 or 29. So you add 14.29 to both sides. They cancel out. Got x equals 39.29. All right, those are truly one-step equations, guys. B, I'll do the top one, I'll do as a one-step. I'll do it as a two-step equation. Okay. Because there's a fraction, guys, I would consider this multiplying 8 by both sides. That gets rid of my dividing by 8, my denominator of 8. And so if I multiply the left side by 8, I'm going to multiply the right side by 8. My left side would then just be negative 5x equals 160. I divide by negative 5. And I'm going to get x equals negative 32. Okay? I did that as two steps. I multiplied, then divided. Okay? You can also get rid of a fraction by, it's called multiplying by the reciprocal. Guys, it looks slick. You're going to multiply by 3, divide by 2. Multiply by 3, divide by 2. What are you actually doing? Still two steps. Negative 18 times 3. You can take your calculator. Negative 18 times 3. Negative 54. Then you're going to divide by 2. Negative 27. So really, still kind of two steps on the calculator. but they consider that to be one step if you multiply by the reciprocal. Okay, either way works. We got rid of the fraction. Either way, got the right answer. Okay, so there's one-step equations, what they consider one step. And guys, these next couple of examples, there's some multiple steps. You guys can see there's going to be some distributive property, maybe some combining like terms. I see there's x in both, or on these left side, there's a couple x terms. Okay, so solving these multi-step equations, like I said, applying the properties you guys know from Algebra 1. So the distributive property here first. Distributive property again. Okay, combine like terms. 3x plus 17 equals 14. Subtract 17. Divide by 3. Okay, so that first one you get x is negative 1. Guys, 5b is very similar to distributive properties. 5a, there's only one distribution, so it's negative 10x plus 12x, 3 times 4, and minus 3 times 2 is 6 equals 6. Combine your like terms, that's 2x. Negative 10 plus 12 is 2x. Minus 6 equals 6. Add 6. 2x equals 12. 4x equals 6. Okay? 5b, like I said, just two distribution properties. I'll go through this one pretty quickly here so you guys can make sure you get a good idea here. 4x minus 2 minus 12x minus 4 equals 2. Negative 8x, 4 minus 12. Negative 2 minus 4, negative 6. Add 6. Divide by negative 8. You got x equals negative 1. Alright, guys, remember, work on that homework. I know the equations you guys are going to be good on. This can be a struggle. Certainly put some thought into that. Those first types of problems, that 1 through 6, where you're translating. Okay. Everyone have a good